I'd like to start by thanking you for coming out tonight to this update on the work of Project Discovery. My name's David Kelly from the SAHMRI Wellbeing and Resilience Centre, and I'll be emceeing tonight. Firstly, we would like to acknowledge that this land that we meet on today is the traditional land of the Kaurna people, and that we respect their spiritual relationship to the country. We acknowledge the Kaurna people as the custodians of the Adelaide Plains region, and that their cultural and heritage beliefs are still as important to the living Kaurna people today. As most of you know who were here at the launch earlier this year, Project Discovery is a collaboration between SAHMRI and the Neil Sachse Foundation, that it's researching positron emission tomography of the spinal cord in order to revolutionise the diagnosis and prognosis of spinal cord injury and other spinal pathologies. Tonight you'll be hearing from Neil and a range of other speakers who'll talk about the importance of Project Discovery and update you on the progress so far and our work going forward. So to start that off, I'd like to introduce the Professor Steve Wesselingh, who'll set the scene for Project Discovery. Steve is the inaugural Executive Director of SAHMRI and also serves as the Infection and Immune Theme Leader for the Institute as well. So thank you, Steve.
Thanks very much, and on behalf of SAHMRI, I'd really like to welcome you here tonight, and I know it's a busy time of year, so I really appreciate the time you've taken out of your busy life to come and listen to us tonight. Project Discovery really is an inspiration of Neil's, actually. I really have to acknowledge Neil's inspired leadership of Project Discovery, and Neil will be up a little bit later to talk to you. But it really is a coalescence, I think, of Neil's inspiration and exactly what SAHMRI does and should do, and that is collaborative science. And so SAHMRI was set up as an independent medical research institute, a flagship institute for South Australia. And but a couple of things were important about the way SAHMRI was set up, or I guess, as John Shine has put it, important things about the DNA of SAHMRI. And the two bits that are really important are collaboration and translation. So firstly, when we set up SAHMRI, we purposely set out to engage all of the partners in SAHMRI, and that included the three universities, so all three universities are involved with SAHMRI, the health department, and all the hospitals in the state. So it was a very collaborative process, and a little bit later down the track, CSIRO. So we really did bring everyone into the tent to work on SAHMRI. And then we were particularly focused on developing research that was aimed at what I call the right-hand end of the discovery continuum. So answering questions and delivering answers that would impact on health. And so every time a project comes up, we ask the question, how is this going to impact on health and in what timeline? And so Project Discovery is exactly one of those projects. It's answering some critical questions, and you'll hear about those a little bit later tonight, about spinal cord trauma, and it's intending, with the answers to those questions, to enable people with spinal cord trauma to get answers more quickly and hopefully better management. And so the collaboration piece of that is that no one can answer that question by themselves. There's the clinicians, the surgeons, and they're in the room tonight, who are involved with spinal cord injury. There's people who are involved from our mind and brain theme, and Julio will talk about that, in terms of the aspects, the neurological and neuroscience aspects of that. And then there's the imaging aspects in terms of developing molecular traces which can dynamically view what's going on in the spinal cord rather than statically view it with traditional imaging. And so again, I think that's the advantage of an organisation like SAHMRI, because of the way we've developed SAHMRI across our 7 themes and with the infrastructure that we've put in the building. It enables us to go all the way from the neuroscience down to the cyclotron in the basement in terms of making the traces, into the animal house in looking at the experiments that we need to do and utilising imaging capacity we have there in terms of utilising PET scanners and MRIs for mice, and then back into the human and understanding and testing our ideas and our processes in humans. And again, that collaboration, I think, is also evident when we look at the precinct. So when you were coming here tonight, you would have seen the University of South Australia building just coming out of the ground, the University of Adelaide building shooting out of the ground. Actually, it's much bigger than I thought it would be at this time already, and obviously the new Royal Adelaide, which is going to open next year. So again, the precinct, I think, is also reflective of that collaborative ethos of bringing the universities, bringing researchers together very close to healthcare delivery, close and integrated into the critical mass of infrastructure that's required when, as I mentioned, where you have a cyclotron, amazing imaging, and then delivery of healthcare next door. So all of that really is epitomised in this project, and it was Neil who identified that opportunity, came to us and said, can we work together on this? And we said, of course, that sounds terrific. Brought together the team, which you'll hear about from tonight. And I think this is just a terrific example of what can be done at SAHMRI, and I utilise it a lot when I'm talking about the opportunities that SAHMRI brings. The last point that I wanted to mention was the human imaging, and I didn't mention that was in the building, but we are a long way along with our plans. You can see the only part of the building that hasn't been developed is right next to us, and there's an empty pod right next to us, and that's where that a human imaging pod is going to go, and so that will enable us to move, as I said, along that bioscience pipeline from cells to animals to people, all in the same building, and we're very excited that's proceeding. And the people involved in that imaging, like Delan from Nuclear Medicine at the Royal Adelaide, and the Andrew from Jones and Partners, etc., are also a critical part of this whole process, so that at the end of the day, we have a sustainable, functional diagnostic that enables us to manage people with spinal cord trauma a whole lot better. So we're really excited about it, and I think you'll hear a really intriguing and exciting story tonight from each part of that puzzle, from each one of our speakers. So again, on behalf of SAHMRI, welcome, and I'm looking forward to hearing from the speakers and how it's going as well. So thank you.
Thanks for that, Steve. Look, I'd now like to welcome Neil Sachse to the stage, who's going to talk a little bit more about the Foundation and Project Discovery. At the launch that was held here a few months ago, I acknowledged that I was a huge fan of Neil's as a footballer playing for North Adelaide, and I know that there are some people in the room who remember him as a footballer and what an amazing player he was, and what an amazing part of those North Adelaide teams from the early 1970s, when effectively North Adelaide Football Club was the best AFL team in Australia at the time, and Neil was a really important part of those teams. Look, the same dedication and commitment and courage that he showed as a player, he's brought to his work with the Neil Sachse Foundation and to this project. It's that courage and that dedication that sees us sitting in this room tonight talking about Project Discovery. So, Neil, I'll hand over to you. And straight into the video.
Yes, please.
Okay.
Come with us on a journey of discovery. A discovery so profound, it will revolutionise the way we will diagnose and treat spinal cord injury. This journey is a world-leading research project. As it stands, understanding the precise nature of spinal cord injury and the best way to treat it has been limited. Magnetic resonance imaging, or MRI scanning, has been the best way of imaging the spinal cord today. However, it doesn't paint a complete picture. Imagine a still photograph of a busy city street, traffic, people and buildings. In its simplest form, that's how MRI presents a spinal cord injury. Now imagine if we could bring that photograph to life and we see the same scene not only in motion but also dimension. This is called Positron Emission Tomography, or PET scanning for simplicity. PET scanning is already used for brain exploration, but has not been used to image spinal cord. We want to change that, and what a change it will be. Once this world-leading PET spinal imaging is researched, tested and developed, it will provide a much more accurate diagnosis. It is imagined it will provide more accurate prognosis for the injury, so patient expectations can be better identified. It is anticipated that we will also be able to measure functional response to treatment and identify preferred treatments. It will also provide imaging services to identify functional nerve growth. Up until now, none of this has been possible. Consequently, many people who have suffered spinal cord injury, whether in sports, recreation, motor vehicles or at work, have had their lives cruelly limited and have suffered great pain. We call this journey Project Discovery. Project Discovery is an initiative of the Neil Sachse Foundation and the South Australian Health and Medical Research Institute's Mind and Brain Clinical Research Division. There is much work to do on this journey, but the prize at the end will benefit spinal cord injury sufferers here in Australia and all around the world. Project Discovery is a journey we must take. We ask you to come on this journey with us, and we ask you to spread the word, and if possible, financially commit to the developmental research phase of Project Discovery.
It's heavier than I thought it was. It must have been a long time since I've spoken on a microphone. Thanks everybody for coming along. Really appreciate you being here. What I'd like to do is perhaps start with my story, my life a little bit, just to give you an understanding where I am. Back in the 50s, I was one of 3 boys. I was the middle, and we were very competitive, so we used to compete in whatever sport we did. There was no TV or anything like that back in those days, so all there was is to go get out in the backyard and compete against one another. I don't know whether that set us right for our life ahead or not, but it was that competition that I suppose keeps everybody striving. One of my passions wasn't schoolwork. When I went to school, it was sport, so I used to get out and play any sort of sport that I could do to avoid going to actually do education. One of those was football. By the time I was 15, I'd played in 7 grand finals, losing only one. My older brother had done something similar, so he went up to North Adelaide through the under-17s, 19s, playing league. So while he was doing that, I followed his footsteps, because once you went through the under-15s in the local league, there was either keep on going or you're invited to go to things like the local SANFL side. So I went with the under-17s. In the second year of that, we played. We won every game that year except the grand final, which is something fairly sobering when you've won so many. By the time I was 20, I was playing league football and played my first state game and first grand final, and were lucky enough to win that. I'd been known to be fairly, somebody told me anyway, that's what the media used to tell me, I was fairly aggressive, so I used to get reported fairly often, and so what they suggested was bide your time and catch up with them later. So one of these times came, and so I hit this guy and broke my thumb, and so in 1972 I missed the grand final again, so it doesn't pay to do that either. So by that time, I think that was the last time I ever got reported. So I gave up all those sort of things the last time I was injured, except for my final injury But 1973 we played Glenelg and lost. And I think losing grand finals or losing things makes you more focused and more driven. I was invited to go to Footscray at the time, and so I accepted that. In 1975 went over, and in the second game, 2 hours before the end, or 2 hours before the end, about 10 minutes before the end, I broke my neck in an on-field incident. I didn't know what a spinal cord injury was at the time, so all I know I was being picked up and I couldn't move. I got taken off on a stretcher, and I still didn't understand what was going on. They said they were going to take you to hospital, so I said, you better take my boots off. They said, we did that a long time ago. So that's when I knew there was something perhaps more serious. So they took me into an ambulance, and off I went to hospital. There they proceeded in sticking pins in me to see what sensation I had, and that they give you a pinprick to identify what level of injury you are. So they prick you, find out what the sharp sensation is, the dull sensation, and if there's no sensation at all, then they can determine what level of injury you are. Unfortunately, that still happens today, and one of the reasons I got behind, I suppose, spinal injury is to make things different to what I did. I know my footage of my accident has changed a lot in the way that they treat people, so everything is much safer, from sports to motor accidents to whatever injury somebody gets. They're always treated differently to when I had my injury. So there was a benefit that came out of my injury to society, and I suppose with the foundation, my aim was to do something similar. And this project Discovery with a new imaging system, instead of waiting 12 months for the swelling to go down and having some correct diagnostics, with this new imaging system it will happen within a week, so people will know what sort of level of injury they are, because the idea is to image the intact nerve cells alive after an injury. We know that it's a difficult task, but we feel it's a task that can be done. It'll also allow for new treatments at the time of injury to be seen if they're making any difference, or any new treatments become available for older injuries. So we see it's the most important piece of the puzzle is to see what's inside of a spinal cord, so that if there are any changes or any treatments, you can see that difference. And that's why we're here tonight.
Look, thanks very much, Neil. I'd now like to welcome to the stage Professor Julio Licinio. Professor Licinio is the Deputy Director for Translational Research at SAHMRI, and also the theme leader for the Mind and Brain theme, as well as being the Matthew Flinders Distinguished Professor of Psychiatry at Flinders University. Julio today is going to actually talk about some of the research that will be undertaken that's been particularly opened up by this collaboration with the Discovery Foundation. So thank you.
So first I'd like to thank all of you for being here at this hour in December, and also particularly to Neil for having been the inspiration for this and the driving force. Yes, so what I'll be talking about here is just a very few slides to give you a general idea of what Project Discovery is in terms of the nitty-gritty of the actual projects. So this is a collaboration with SAHMRI, where you are now, the Royal Adelaide Hospital, that's represented here by Professor Brian Freeman, who is a professor of spinal surgery there, and of course a Neil's Foundation, and he has this new campaign connecting the dots with spinal cord injury research. So I put the three components there so you can have some idea of how we'll be working together on this. So just a very brief overview of, because you hear a lot about PET scanning, and there was a component that I, even myself, had written part of this proposal, was not completely aware of. So I think it's good to give people like a general background. So it's a very powerful imaging method which measures not only the structure but the activity of what's happening in a place. So what we do is that we create, and you'll be hearing more about that, we create, and Prab Takar, who is the head of our MITRU, the Molecular Imaging Therapeutics Research Unit, is here. So we create specific compounds that bind to specific parts of the brains, of the body. So you could have a glucose that goes to parts which are using energy. You could have something that's like a compound that goes to a specific receptor. So you have this radioactive compound that you can see there in the orange here. And then it binds to its target. And this kind of reaction between the compound, the radioactive compound and the target, generates gamma rays that can, in both directions, that can be measured in a machine. And then because you see where the radiation is coming from, you can estimate its source, and then you can map out the source of this encounter. And that's what the PET scanning is. So there are three major uses for PET scanning to evaluate a traumatic spinal cord injury. So we could measure metabolic activity within the live tissue following spinal injury, which we can do by a PET, and you'll see a picture of that. So in other words, when you get conventional imaging like an MRI or a CAT scan, you have a picture like a still picture, so you don't know if the area is damaged or not, but you don't know if it's alive or dead. And that can make a big difference, because if an area is alive, then there's much more that you can do. So you can also estimate the degree of connection of spinal fibers after spinal injury. And when there is, and usually when we think of spinal injury, you think of something as kind of dramatic and rapid as what happened to Neil. But it can also be degenerative. You can have lesions of the bone that are chronic and then keep squeezing the spine, decreasing the size of the spinal canal, which is already narrow to begin with. That's called cervical spinal stenosis. And then you need decompressive surgery to kind of clear that and open it up. Otherwise, you cause permanent spinal injury. So through Project Discovery, you propose to develop here, which would be Australia's only dedicated PET scanning center of the spinal cord, with 4 initial goals. So the first one would be to use glucose and information target ligands to image the human spinal cord in healthy individuals. So first of all, before we can even kind of see the degree of injury, you have to make sure that you have your tools are optimized to assess what's healthy, and then you can see what's different from healthy. But if you're not optimized to assess the healthy situation, then it's kind of difficult to make clinical use of something in a disease situation. So the 2 ligands that I put there, the first one is glucose. Essentially, it's labeled glucose, so it just tells you where there is uptake of glucose, which means that the tissue is alive and there is metabolism there. And the other one is targeted to areas of inflammation, which happens after spinal cord injury or many other types of injury. The other study will determine whether PET scanning of the spinal cord has predictive validity to measure areas that are injured but still viable and have the potential to recover after surgery. So the results of this kind of study can be rapidly translated to more aggressive use of surgery and post-surgical rehabilitation in case they have the potential for clinical recovery. So if you show that there is an area of tissue that is still alive, I think you would be much more aggressive, both at the time of diagnosis, acute treatment, and also a long-term rehabilitation. If the tissue is dead and is not responding at all to the ligands that you give, I think that the prognosis would be much more limited. And then if we do these 2 projects, we would be very ready to launch future studies to look at potential new treatments. And the big problem that we have with potential new treatments now is that when you give a treatment, especially when it goes to human trials, you have to see a clinical improvement. And there is a huge gap that goes from the injury to actual clinical improvement, as Neil was describing the pinpricks. So something could be beginning to work, could have a mild effect, and something that you should try to increase the effect. But if you don't see the clinical response, you'll just say, well, there is no response here. But with imaging, you could say, well, there is a 20% or 30% degree of improvement that's not manifested yet clinically. But this treatment is creating more activity in the spine. And then there will be much more investment in that kind of treatment as opposed to something else that you say, okay, you do this thing here, and there is absolutely no PET results data. So I think that that would permit us to assess new treatments in a much better way than what we do now. And we may be throwing away things that may have the potential to work if we tweak them, that we wouldn't be doing that, throwing it away, if we had tools to assess them more precisely. And I think a new milestone for Project Discovery would be to create here at SAHMRI what already exists in other parts of the world, which would be inflammation-targeted markers that would detect in a living patient an area of active inflammation in the spinal cord and in the surrounding tissue. So you can see how much inflammation, let's say if you use this compound and do the PET scan, you could see how much inflammation is there. Then if you do different interventions, you can see if the inflammation is decreasing and how that may contribute to improve the person. So I put some examples here because a picture speaks for 1,000 words. So just showing how you can use PET to assess the spinal cord. So you can clearly see the spinal cord there. It's pretty obvious. It's right here. So that's the spinal cord in a very sad case of someone who had a lymphoma, non-Hodgkin's lymphoma, that spread to the spine. And then they use a kind of PET scanning that's used to assess tumors. And you can see the spine lights up very clearly in this case of non-Hodgkin's lymphoma of the spinal cord. So this shows that you can really see the spinal cord in PET. And it's not an ideal situation, quite the opposite, but you can see the potential utility of this method. This is a study in a rat, in a paper that was published some years ago, in which there was what's called contusion of the spinal cord. So you get the animal and you cause a contusion in the back in an area that will hit the spine. And you can clearly see here the area of contusion with PET, and the spine is here. And they could measure, here's the spine, different levels of spinal activity following the contusion. So it can be used in an animal model to do what we're proposing to do here. And it's always important when you do human research to show that there is a precedent in an animal. Then this case is very interesting. I just saw this very recently. It's from the Journal of Nuclear Medicine last year. Remember that I told you that some people don't have the acute injury, but they have this chronic bone degeneration and then kind of a squeeze the spinal canal, and they end up with, can end up with severe injury if it's not operated. So this person had the stenosis here, you can see, and by just looking at the picture, this spinal cord here could be completely damaged and, kind of could be like more of a very green prognosis case. But what the PET scanning showed is that there is very intense activity there. So the tissue is very much alive. So the person was operated, which they would be anyway, but you can see that this patient had good clinical recovery 6 months after decompression of the stenosis. And let's say hypothetically, if it was the opposite, if there was no activity here, you would say, there isn't much that's going to happen here. So in this case, probably you would invest a lot in terms of rehabilitation and therapy for this person and accelerate the surgery. And the last data slide that I have here was about the inflammation PET scanning, that this group in France used a very similar compound to what we're going to be developing here that targets inflammation. And they used a model of a spinal cord injury that's a little different from what we've been discussing, which is an inflammation model, but instead of causing inflammation by contusion, by physical force, they give us all the nerves in the body are covered in myelin. It's like a protective sheet against every nerve fiber is covered in this protein called myelin. And the body recognizes it as its own protein, so there is no immune reaction. But as is the case with many proteins, if you get it and just break it into different sizes and different shapes and just throw it, inject it to the animal, or could be a person, they develop antibodies against it. And then the antibodies go against the person's own myelin. So you have what's called inflammatory reaction towards the nerve cells. So when you do PET of the spinal cord here, here's the control animal without injected with just the saline, without the myelin that would cause the antibodies. And you can see the spine, you don't see the spine here because there is no inflammation. And so that's kind of a cutting across, and this is lengthwise. You can see the spine here is this black area because there is no activity. And then in the animals, there's this experimental autoimmune encephalomyelitis. They have inflammation, so you see that the area is filled. So here there is a lot of imaging noise in the surrounding tissue, which you can address by subtracting it with using computers. So essentially here you only have the area of lesion, and then you can put color in it. You can see exactly where the inflammation is, which is along the spinal cord. So you can actually map out inflammation on the spine in this animal model. So everything that we're proposing to be here is really based on existing work, but nobody has gone the next level, which is to apply to humans the way we're planning to do it here. So I think we have a lot of opportunity to develop something really important and creative through Project Discovery. Thank you. And my last conclusion slide is that Project Discovery represents an exciting opportunity to come up with new approaches for spinal cord injury. So molecular image can guide diagnosis, prognostic assessment, treatment assignments, and evaluation of new treatments. And the ultimate goal of the project is to improve outcomes in spinal cord injury through advanced assessments of the living injured human spinal cord tissue.
Thanks, Julio, for that really exciting insight into the possibilities of the research that will be coming up in the months and years to come. Look, I'd now like to invite Prab Takar to come to the stage. Prab is the director of the SAHMRI Molecular Imaging and Therapy Research Unit, and he's going to be talking particularly about the potential for medical advancement that is envisaged through Project Discovery.
Thank you. So I'll actually leave this slide up because it's actually a good representation of what we're trying to do. And I don't want to get clapped twice. So one of the things I really want to describe is exactly what we've been trying to do with the cyclotron being in this building and the collaborations that Steve's talked about as well. So the cyclotron is in a unit downstairs. It sits 20 meters underneath, and what we do physically there is actually make things which are non-radioactive radioactive. But that is a simple, easy step, in a sense, when you've got a big particle accelerator. What you really need to do is make that translational, and that's where SAHMRI comes in. What we're trying to do is effect change and actually see those agents go from their clinical work or preclinical work that is being sent into a clinical environment. And what we want to do is be able to see that occur in a short time frame. So when Neil and I were having a little bit of a chat when we were trying to make the decision about which direction the Project Discovery was going and everything else, he turned around and said, I just wish we could just look inside the spine and see what's going to go on. And I actually said, there is this prototype compound out there, but it's going to cost a lot to make it happen. But if we could do it, we could actually affect change a lot more in these patients. And then talking to Julio and talking to the different members of the teams, we thought, is this going to be possible to do? And it is a big, what's called, step to jump from something which is in a research facility directly into going into humans. But I think one of the big advantages that SAHMRI has here is that when we built the facility downstairs, we built it to be able to be a federal facility, which basically means that we've got the level of standards that are required that we will be able to go directly into humans. It means that we have to follow certain protocols higher than most other sites across Australia. But what it means is that anything that we create here can be actually copied and used around the world. And I think that's the decision, which was a really good decision way back before I even joined the project, SAHMRI. But then when Project Discovery came along, now you can see a conduit that can occur from where you go from a simple molecule all the way through into humans. And also all the availability and all the things that you can now uncover from that. And I think that's the big advantage that we've got. So we've just, as Steve mentioned before, we've got the bioresources with all the different imaging we have the ability to do, which means that anything we design or say that this is what we want to do long term, we can actually evaluate early on. So we can also do human work as well as the work that we need to do in mice, which is required to make sure that any of these new treatments that come about, we can actually do a real experimental check on those as well. So I think treatment verification is one of those most important things, but diagnosis is the first and fundamental. And just meeting all the wonderful people that Neil's introduced me to over the last I don't know how many months it's been, about 6 months, I've suddenly realised that the change that we could actually affect is something that we all want to do. And it's the state getting behind us as well and pushing forward, and all the grants that we've been able to apply for. And Project Discovery has opened a whole kind of plethora of agents now into the mind area as well, which we hope that this will be the first stepping stone to show what we can actually achieve in just a simple place like Adelaide. But what we can do is show what we can do here, in Australia and globally. And I think that's one of the things that I've just suddenly realised listening to what's called Steve speak, as well as Neil, about the effective change that we can do. And competition is good, absolutely, but what we also need to do is be collaborative as well. And collaboration, especially with the Royal Adelaide and Delan and the team that's over there, has actually helped us speed up the process. And I think what will happen here from this project is that we'll grow further. And I'd just like to say a big thank you to a lot of the work that Neil's and all the people that Neil's introduced me to, who've given me and my team a lot more emphasis about working faster and getting this done. So hopefully in about another 9 months' time, we'll have that agent available and being able to be injected into our first human. So I'd like to thank everyone who came tonight as well, but here comes the next future. Thanks.
Thanks, Prab. That's great. It gives a real sense of the urgency and the reality of this and the impact that we can make on real people. So look, our last speaker for tonight was going to talk more about that treatment side of things. And I'd like to welcome Professor Brian Freeman, who's the Professor of Spinal Surgery at the University of Adelaide School of Medicine, but also the Head of Spinal Services and Consultant Spinal Surgeon with the Royal Adelaide Hospital. So thank you, Brian.
Excuse me 1 second while I load this talk. Okay, thanks very much. It's a pleasure to be here and to talk to you a little bit further, maybe more about the clinical side of things and the basic science. But what I'm talking about here is, as you've heard from previous speakers, talking about advanced imaging to benefit our patients. And we've just celebrated 175 years of the Royal Adelaide Hospital, and it's very exciting times now with SAHMRI fully open and the new hospital close to opening next year. It's a very exciting time for all of us, and very excited to be involved with SAHMRI and the new hospital. We're very excited about starting work there next October or November, maybe. So as you've heard, spinal cord injury is a catastrophic neurological event, both for the individual and for society. The cost for a patient with paraplegia is around $5 million, compared to someone with tetraplegia is around $9 million lifetime healthcare costs. And as you've heard, there's no proven treatment. These CT and MRI scans were taken of a 19-year-old male who, in the blink of an eye, as a result of a motorcycle accident, became a C5 complete tetraplegic. Now, as Neil said, what these pictures show is a very precise pathoanatomy, but it doesn't show us anything to do with the function of the spinal cord. We rely on this neurological assessment. It's a very detailed assessment, and the whole process can take up to an hour if it's done properly. And quite rightly, as Neil said, it involves a fairly comprehensive assessment, including rectal examination, rectal sensation, power in all the muscle groups, and this gives us some idea, but it's really a difficult diagnosis in those early stages, particularly when the spinal cord may be in shock. Here you can see this individual underwent a fairly complicated operation to realign the bones, to decompress the spinal cord, and to stabilize the segment. Despite this work, within several hours of this poor man's accident, he made no recovery. So whilst you can see that the CT scans will show the bony anatomy and the MRI scans show the soft tissue, in particular the spinal cord, but neither of these imaging measures give us any idea about neurological function or recovery. So we are constantly seeking to provide a more accurate diagnosis and prognosis for these individuals with spinal cord injury. And you've seen this slide already, but I just might spend a minute or two explaining it a bit more in detail. It gives you some idea of the power of PET. This is a patient with cervical myelopathy. It's a chronic condition where the spinal cord is being pinched by a prolapsed disc in this case. And you can see in this picture the subject has been fasted. He's not allowed any glucose for 12 hours prior. He has an intravenous injection of the isotope, and this is taken up in areas of high glucose utilization. The PET scan is then performed 1 hour later. The current resolution is not ideal. It's at 5 millimeters. We hope to increase that resolution to less than the 5 millimeters that we've currently got. And you can see that if you compare the MRI scan, which shows a lovely anatomical picture but no function, and now you look to the right of the slide, and you can see increased uptake at the level of the narrowing. In this instance, the doctors treating this patient were able to advise a good prognosis. The patient underwent decompression, and in this particular case made a very impressive neurological recovery. So in this situation, the PET scanner was able to tell us that the spinal cord damage was reversible. If, on the other hand, we look at this case, which I would suggest, if you look at the MRI scan, looks similar to the past case, in that there is some signal change within the spinal cord and some narrowing, particularly at the C3-4 level. When the PET scan was carried out, however, it showed very poor uptake at that level and below the level of injury. This patient underwent exactly the same operation as case A, but made no clinical improvement 6 months after decompression. So in essence, this was a case of permanent damage, and the surgery was not going to help this individual. That's what we're hoping PET will do with us and spinal cord injured population, to identify early on those that have an incomplete injury and are likely to have a good prognosis, and to those that don't have such a good prognosis. You've heard a little bit about the PET CT, and it's a combination of tomography and CT. The images are then joined, and we're reliably informed that we'll be getting not one but hopefully 2 new PET CT scanners in the new hospital. We have one at the moment in the, for want of a better word, old Royal Adelaide Hospital, and that is working flat out at the moment, mainly with patients. There's very little time on that scanner for research, and that's what we're hoping we'll get some research time on the new PET CT scanners. So, in summary, the combination of PET and CT it really is a powerful imaging tool to measure both the structure and the function. The animal studies have demonstrated a clear proof of concept. So our aims here are to measure the metabolic activity throughout the spinal cord following cord injury, to improve that resolution. 5 millimeters is not sufficient for us at the moment, but to also track spontaneous neural recovery. About 2/3 of spinal cord individuals are incomplete and likely to develop some neural recovery. We'd like to track that with serial PET CT scans. And as you've heard, there are a whole host of basic science projects that we want to study in tandem with this imaging study, looking for strategies that will work on the immune or stem cell side. So the team you've heard about, Julia and Prab, you've heard speak. Gillian Clark, I can see, is in the audience, and we're very grateful for your help, Gillian. Dylan Bartholomew is the director of the PET scanner in the Royal Adelaide Hospital, and we've had several exciting meetings together, and we're currently working on the protocol. We're going to start with individuals with established spinal cord injury and start to image those hopefully within next year. The protocol is part written. We're seeking ethics applications approval, and we'll go from there. So I thank you for your attendance, and I thank you for all your support, and we look forward to keeping you updated as we move through these various projects, and thank you again for your time.
Look, thanks very much for that, Brian, and once again, to get that whole cycle revealed to us tonight as we move from research through to treatment is really exciting and indicates how much work's been done over the last period of time. So we look forward to more updates like this as we move further down that path and have more to report. Just to finish off tonight, there are a couple of comments that Neil wanted to make. So unless there are any other questions, any other comments, I'll hand over to Neil now.
Thanks again. Just like to thank our MC. He's done a great job tonight, and I think I should pay him next time. He might do a better, might give me less a rap. Just to give you a brief update on how this project actually happened. We got introduced to Jenny Hurley, and at the time we were working on a particular project, and all of a sudden that stopped, and we were scratching our head on where should we go from here. So Jenny said, I know Raymond Spencer, so within a couple of days she had Raymond Spencer at her hotel, and we were meeting with him, and within the next week Raymond introduced us to SAHMRI and Steve Nicholson, because he was stepping in at the time for Steve Wesselingh, because he was overseas. And next minute Julia got involved, Prav got involved within about a month we had a project. And all of a sudden we needed the Royal Adelaide Hospital, and I knew Brian Freeman. And within a number of days we got hold of Brian Freeman, and so the project pretty much grew teeth. We got the project outline, and then we started going for funding. And within 6 months we've almost raised $600,000 in that time frame. Thanks to a number of key players. One is the Lifetime Support Authority, who's given us $200,000, the Independent Gaming Commission, who have given us $167,000 to get that particular piece of equipment so we can make that isotope that we can inject. So, you know, it's those sort of bits of funding that make a difference, and Jenny has contributed herself and got a number of other people involved to contribute as well. There are more than one ways to support this particular project. It's not only financial, but if you can spread the word, that also helps get the message out there of what we're doing, and you know, never know that they might come across somebody that might be able to help us as well. So I'd like to thank all those people involved, and particularly SAHMRI for their help and their work. Brian, the Royal London Hospital, Delane as well, and now with our involvement with YH and Eleanor, it's making a big difference on another front as well. So thanks again for coming, and appreciate your time. Just before I go, something I nearly forgot, I'd like to introduce you to Brent Reilly, who's, I don't know whether you know his background, but he has been a footballer for the last 12 years. Unfortunately, he got hurt in a training accident and had to retire from football. He's come on board as our project manager for Project Discovery, and really look forward to his help, and I'd like him to come up and so you can meet him. You might have seen him on a football field, but not in real life.
I have to now, don't I, Neil? He's still in the show. No, bit of my background, obviously Neil said, played footy for 14 years for the Crows, and unfortunately fractured my skull at training and had to retire from football, and got in contact with Neil through Jenny and through Ray. So Ray's my mentor and looks after me, and SAHMRI's been kind enough to give me a bit of a role under Neil's guidance, and yeah, just looking forward to it. It's a good concept, and I'm looking forward to working with all the crew here and making it all make sense to me. It's taking a while, but eventually I'll get there, and I'm really looking forward to it, and I really believe in this concept, and hopefully we get to where we want to go. Thank you.
So look, thanks very much, ladies and gentlemen. We really appreciate you coming tonight. I'm sure this will be the first of a number of updates that we'll do over the life of the project. And thank you for your support and your time. And as Neil said, please spread the word too. So look, thanks very much, and we'll by all means stick around for a few minutes and talk. That would be great. Thank you. Thanks, Neil. Pleasure.